Atmospheric circulation drives Earth's wind patterns. It occurs due to uneven solar heating and pressure changes between the equator and the poles. Different parts of the Earth are warmer than others due to the difference of direct sunlight. The equator gets the most direct solar radiation, making the air hotter and less dense. This causes it to rise and create a low pressure area at the surface. The poles get the least amount of solar radiation, which makes the air there colder and denser, causing it to sink and make its way to the lower pressure surface. This is called convection. A physical representation of this will now be shown. In this representation, the red water represents hot air and the blue water represents cold air. As I add the cold water, you can see how it sinks immediately. The colder it is, the more dense it becomes, causing it to sink. When the hot water is added, it rises to the surface and remains there. As you can see, the two layers don't mix, and you can actually see the room temperature water remain undyed. Just like this water, cold and hot air works the same way in the atmosphere. The rising of hot air and falling of cold air creates circulation convection cells. Air near the equator rises, flows towards the poles, cools, and then sinks. Thinking about the Earth's atmosphere like this, George Hadley came up with the idea that there is only a single circulation cell in each hemisphere. However, the atmosphere is a little more complicated than that. There are actually 3 different circulation cells in each hemisphere, and this is because of the Earth's rotation. When the Earth rotates, different parts of the planet move at different speeds, which causes the Coriolis effect. If you think about a merry-go-round, the outside goes a lot faster compared to the middle. Earth works exactly the same way. As air moves into these regions with different speeds, its path is pulled sideways instead of straight. This bending motion is called the Coriolis effect. The bending of these paths is what breaks the atmosphere into 3 different circulation cells, all which are driven by the motion and exchange of hot and cold air. Atmospheric circulation is driven by changes in temperature, pressure, and Earth's rotation. Warm air rises, cold air sinks, and the Coriolis effect bends these moving air masses into organized wind patterns. So the next time you feel the wind, just remember that that's hot air rising and cold air sinking.